Hello everybody, so today we're going to talk about a category of 3D shapes called prisms. Now you may not have heard the term prism before, but a prism is any shape that we can cut through a cross section of at any point and the shape will still be the same. So we can have a prism that is triangular, and no matter where we cut through this prism, we will always get a triangle that is the same dimensions, like this. We could also have a prism that is, say, in the shape of a cross. And as long as it has the same shape anywhere we cut through the cross section, then that is still going to be a prism. So if we were to cut through this shape at any point along it, we would still get a cross shape like this with the same dimensions. A prism can also be a shape that has a completely random side on one of its edges, but again, as long as this side it's the same shape and we can go to cross section through it at any point, then it's still a prism. So you can see here the surface B is essentially a random shape. It doesn't fit into any of our normal descriptions of shapes, but if we were to cut a slice through any part of this prism, we'd still get the same shape B, which is actually what we see up here at the top. So this also still counts as a prism. This picture here is actually from our log tables, which gives us the general formula for the volume of a prism. What we need to do is get the area of the cross section, so this shaded section B, and multiply it by the height, or how far back that cross section goes. And this is the same way of calculating volume that we apply to all prisms. So we can use this as an example for a cylinder. Cylinder is a circle that goes back into 3 dimensions and has the same cross section throughout. So we can slice this at any point and we get the same shape, making it a prism. For this cylinder here, we'll say that the radius is 3 centimeters. And we'll say that the cylinder has a height of 10 centimeters. Before we calculate the volume, the first thing we should do is identify the shape like normal. So we know the shape is a cylinder, which also counts as a prism. Now we write down the formula that will give us the volume of this prism. So the volume should equal to the cross-sectional area times the height of the prism. Before we fill this in, we need to actually figure out what the cross-sectional area is. So the area of a circle, you can write as A or B, depending on what your preference is pi r squared. The radius is 3, so we'll fill that in. Now, if the question asks you to find the answer to a few decimal places, instead of putting in pi here, you might put in 3.14. But I'm going to assume that it's asking me to give my answer in terms of pi. So I'm going to leave pi as it is. So if we work out the area at this point, it will be 9 pi centimeters squared. Now we can go back to the formula for the volume of the whole prism. And what we need to do is multiply the cross-sectional area, which we said is 9 pi, times the height, which we know from the diagram is 10 centimeters. This will give us a total volume of 90 pi, and since volume is measured in cubed units, we're going to say centimeters cubed. So we'll look at another example here of a prism, and we can tell this is a prism because it has an L kind of a shape on the front, and then if we cut this through at any point, it will have the same cross-sectional area, that same L shape. So we can try and find the volume of this and also its surface area. So we know the volume of a prism is going to be the cross-sectional area times the height of the prism. So our first task in finding the volume will be to find the cross-sectional area. And to do this for this shape, it might actually be a good idea to draw out the shape separately. And we might actually need to split this up into two smaller shapes because we have something that's a pretty irregularly shaped object here. So we can actually turn it into two rectangles, and that might make life a little bit easier. So this leaves us with two rectangles, one which is 8 centimeters by 4 centimeters and one which is 4 centimeters by 12 centimeters. So this gives us an area of 12 centimeters squared in the top rectangle and 32 centimeters squared in the bottom rectangle. And we can add this together to get the total area of the cross section, which I'm just going to signify as B for now instead of A. So this will give us 44 as our total cross-sectional area. Now to find the volume of the whole prism, we want to multiply the cross-sectional area by the height, remember. So cross-sectional area is 44 and the height of the prism is 6. This gives us a total volume of 264 centimeters cubed. Now I know the volume has to be in cubed units. I'm just taking my lead that it's centimeters based off the dimensions given in the original drawing. Now the next skill I want to talk to you about is drawing a net to give us the surface area of this 3D shape. So we've done this before with our squares and rectangles. What we're going to do is draw out the front of the shape first of all. Once we've got this, and we want to think about the sides that will attach onto each of these surfaces. So what will attach onto the top, what will attach onto the bottom, each of these sides, and so on. So we can start with the bottom. We know there's going to be a rectangle that attaches on here. That's the bottom surface of this prism. We know on the very top, it's also going to be a shape that will attach on here. It's the top of that prism. We know that it's going to have a side on the left and on the right. Now at this point we might be trying to draw a surface that extends out from here, also one that extends up from here. That will not work because they would just cross over each other, so we need to think about a different way of doing that. So what we can do is look at what other surfaces they attach onto. So the surface that comes out from this part of the cross-sectional area, or the front surface, also attaches onto the top. And the surface that comes out of this part of the cross-sectional area will attach onto the one to its left. So we can draw them as follows. So here we can see that the area shown here, I'll shade it in, attaches onto the top, and the area shown here, so the other part of the L, attaches on next to that, because these do flow from the top into both of those two sides, and then attach down to this surface here. Now we're missing one side. We have a front, then 1, 2, 3, 4 bottom, and the other side gives us 6. So we have 1, 2, 3, 4, 5, 6, but we actually still need to draw the back of the shape, so don't be caught out by that. So that's going to be another L shape that attaches onto, really you can do it on the bottom or any of the other sides, and we might do it on this side here. Now if you were asked to calculate the total surface area of this shape, this is how you go about doing it. Draw out a net of the prism and then calculate the area of each of those individual boxes inside it. I'll do this out quickly for you now. So first of all, filled in all the dimensions based off the diagram, and now for each of the rectangular sections I just multiply them out to get the area for that rectangle. So once you've calculated all of these individual surface areas, all we do then to find the total surface area is add them all together. And that would look something like this. And this would give us a total surface area of 268 centimeters squared. Again, this is got by adding all of the individual areas of each of those surfaces.